So welcome to Concepts in Chemistry. In this talk, we'll discuss what changes matter can undergo. Matter can undergo two types of change. The first is called a physical change and the second is called a chemical change. What's a physical change? A physical change is a change with no change in chemical composition of substance, meaning no new substance is made from the starting materials. What are examples of physical change? Examples include ice melting to liquid and then liquid boiling to gas. So, the process of melting and boiling are examples of physical change. Also, if you cool down your gas, it gets to a certain point, the molecules start sticking together to form liquid. So, the process of cooling down your gas to liquid is called condensation. And once you continue cooling down your liquid, it gets to a certain point whereby the molecules rearrange to form ice. So, the process of cooling your liquid to ice is called freezing. So, freezing is also a physical change. So as you can see, physical changes usually involve changes of states. And these changes of states usually occur because of weakening or strengthening of the attractive forces between molecules or atoms. So here, as you can see, in ice or liquid or gas, you haven't really made anything new. You've only caused a change of states because the water molecules in ice are the same water molecules you find in liquid and are the same water molecules you find in gas. So as a result, you haven't really made anything new. Okay, so the only difference is that the distance between the water molecules decreases or increases depending on energy, the attractive forces between them, and also temperature. Okay. So usually changes of states are usually physical changes. Okay. Another example is crumbling a paper. If you crumble a paper and you throw it away, you haven't really made anything new. So that's an example of a physical change. Another example is cutting a piece of cloth into tiny bits. If you cut a piece of cloth into tiny bits, you haven't really made anything new. It's still the same old cloth. You can rejoin back the pieces to get a whole cloth. Okay. So how do we identify physical changes from molecular pictures? Usually to identify physical changes from molecular pictures, you just have to compare the before picture and the after picture. So before and after. So here we do have, the label says water as gas. So how do we know this picture depicts water in the gaseous state? We do know because these molecules are water molecules and they are spread apart with lots of empty spaces between them. So this clearly depicts the gaseous state. And this picture says water as solid, which means water as ice. So how do we know? Here the water molecules are much more closer together with little empty spaces between them. Because of that, we say this is the solid state. Now, in real life, when water molecules arrange to form ice, they usually form hexagonal structures. But because of simplicity, I've drawn them this way to emphasize the solid state. Okay. So as you can see, the water molecules you find in the gaseous state are the same water molecules we find in ice. So we haven't really made anything new. The only difference is that the water molecules in the solid are much more closer together than in the gaseous state. So we say the attractive forces between water molecules in the solid is much more stronger than the attractive forces between water molecules in the gaseous state. So then the reason why the gaseous states have weaker attractive force is because the water molecules do have lots of kinetic energy, so they're always moving about, okay, with little attraction for one another. Now, if we want back our ice, solid water from steam, what we need to do, we just have to cool down our steam. So as we cool down our steam, it gets to a certain point that these molecules slow down. So cooling is a process of slowing down this molecule. That's removing the kinetic energy from these molecules. So as they slow down, it gets to a certain point, they start sticking to one another to form the liquid. And as we keep cooling, again, they keep slowing down, and then the attractive forces between them get stronger and stronger until such a point that they form ice, which is a solid state. So similarly, if we want our liquid or our steam back, we just have to start heating our ice. So as we heat our ice, the water molecules absorb energy, increase their kinetic energy, and then move away from each other, weakening the attractive forces between them until such a point that they rearrange and then form the liquid state. And as we keep heating, it gets to a certain point that they gain so much energy, kinetic energy, and move away from each other, and then they form the gaseous state. So clearly, as you can see, physical change is all about the interplay between energy, attractive forces, and temperature. So what's a chemical change? A chemical change is a change with a change in chemical composition of substance, meaning a new substance is made from the starting materials. So clearly, in a chemical change, we make a new substance. So examples of chemical change include burning a candle, reacting a chemical with another chemical. As you can see, these examples are chemical reactions. So another name for chemical reactions is a chemical change. Okay. So how do we identify chemical changes from molecular pictures? To identify chemical changes from molecular pictures, you have to compare your reactants and your products. So based on this particle model, which chemicals are our reactants? So our reactants are usually the starting materials and are always on the left-hand side of the chemical equation. So here, the hydrogen and oxygen are our reactants, okay? And the hydrogen and oxygen react to make water molecules. So here, as you can see, the water molecules are quite different from the hydrogen and oxygen molecules. So clearly, we've made something new. So this depicts a chemical change. Also, you can see these green lines. These green lines depict bonds between the atoms. So to make a new chemical, that means that bonds will have to be broken and then bonds will have to be formed. So as you can see, the bonds between the hydrogen atoms must be broken, as well as the bonds between the oxygen atoms must be broken, so that to allow the oxygen and hydrogen atoms to regroup to form water molecules. So without this bond breaking and bond making, you wouldn't make a new substance. Okay. So this is clearly a chemical change because our products are quite different from our reactants. Okay, so that is clearly a chemical change.